Okay, so during your design process, you will have multiple options to solve a particular problem, but not all solutions are created equally. What you should do when you have multiple solutions and you need to decide, you can come up with something called a decision matrix. This is a formal way of evaluating the quality of your solutions. So the way to do that is you have your different solutions and you have to explicitly define the criteria at which you're evaluating the solution. And then you define how important each of those criteria are. And so with each solution, you evaluate the score of that solution based off of the criteria. And then the weighted score will be how important the criteria is and then how well that solution scored. You can see an example of this down here where there was a certain electronic problem that needed a solution. So you'll see here the way that this engineer broke down the criteria is the material cost, the performance of that solution, and design effort. And then these were the different solutions. What you want to see is one of the solutions stand out and have a high score. So in that case, this better sensor would be the solution that you pick. Okay. This slide did not load. One sec. Oh, bummer. There was a picture associated with this. Hold on. Okay. So I think there's a modern technology or field called model-based systems engineering that is really interesting, and I just wanted to give you an overview of it. Because as aspiring aerospace engineers, I'm sure that you will encounter this someday. So model-based systems engineering is a way to automate the systems engineering process through a software program. There's a language called SysML, which is a general purpose architecture modeling language for systems engineering applications. The system engineering activities include, but are not limited to, requirements analysis, system analysis, performance analysis, system design, system architecture specification, and system verification and validation, which is kind of incredible because the way that we do it right now is like one systems engineer is in charge of a lot of people who have to come up with requirements, like this is what I'm asking you to do. Then you're going to have to run different analysis programs, and you're going to have to talk to each other again to make sure that everything performs as expected. Then you have to reiterate the design. So all of you people can be automated by something like this that a software engineer can write. But it needs to be written well and carefully. So as I was saying, SysML supports the specification, analysis, design, and verification of validation of a broad range of systems and systems of systems. These systems may include hardware, software, information, processes, personnel, and facilities. SysML is a dialect of UML2, which is some coding language. I won't get into that. But yeah, you're essentially automating the systems engineer's role into computer programming. You are embedding software applications that simulate the mission, like STK, which simulates orbits, structural analysis and thermal analysis software, dynamic simulations, and then the program automatically verifies if requirements are met. So I first saw this at NASA JPL when they were designing the Europa Clipper mission. And they had a bunch of cool simulations that were running in the back end, like there's something called COMSOL, which some of you engineers may have encountered, that is a finite element analysis that produces the thermal distribution of a spacecraft. So that thermal simulation had an interface with this higher level systems engineering architecture. And then that would be hooked up to STK. That would tell you what orbit the spacecraft is in. And then given the orbit, then you know the, like how far the sun is shining on you, how cold the environment is on the spacecraft. It can tell you different environmental parameters that affect the temperature of the system, right? So then you can loop those back to that original thermal analysis and continuously loop and loop throughout the full duration of the mission. So yeah, all of that overhead of humans communicating to each other is instead automated in this software pipeline. So yeah, really neat. Okay, there are some questions about project management tools that maybe I didn't get to. Do agencies such as NASA have people in each department responsible for figuring out their spending? Or are there auditors that inform them that they are going over budget? So for really big programs, you can have accountants and fiscal administrators. Typically, the principal investigators are the ones, principal investigators or program managers are the ones who keep track of the budget and are the ones who pester the engineers that they're going over budget or they're not on track for spending. So hopefully I answered that question.